Hello. Okay. Thank you for being here. I'm Germán Avalen from Uruguay. I live in Mexico. I'm the founder of the EVVM.
Kevin, the CTO from EVVM.
Okay, and we're going to present here the Ethereum virtual machine. Go next, please. Okay, this is the state of Ethereum now. There is L1, L2, many L3s, a lot of infra deployed everywhere. The same happens with a lot of different blockchains. We think that this is fine, but it's a lot, so we are looking for other solutions for scalability. So what we are doing, you have some QR codes here in the presentation that will take you to parts of the repo, to some documentation, everything that is at evvm.org. So what we are doing is solving chain fragmentation with an infra-less solution. What this means, we have about 60K of Solidity lines in smart contracts that when you deploy them, you will have a virtualized EVM environment that you can put it private, you can put rules to access to it on existing blockchain. So you don't need infra. You will use the infra and the consensus of the current layer where you are the deployer, and you will have your own state. So this lets you do a lot of customization. You can have like natively dispersed multi-transactions. You can have executors. That's something that we are going to see. Token whitelisting, a name service, etc., etc. And on security, well, you have your EVVM that is deployed on the EVM. So you have a demilitarized zone if you want. You can be restrictive with who can get in and who can get out. And of course, everything is abstracted. The users can act and operate into the EVVM through a relayer. We call them fishers because are looking for transactions everywhere. Or in permissionless way directly there. So there is also yield generation protocols because when you have the EVVM, all the tokens that are interacting in the EVVM from the whole ecosystem are synthesized and represented into the EVVM, so you can also generate yield using one of these. And you have services that are example swaps, DeFi lending, staking, name services that you can connect to the EVVM that are deployed on the host EVM, and you can get rewards with this as well. So you can use it also as a sandbox. You can code upgrades to the main EVM and in Solidity, and when you deploy, the devs can start interacting with them and you can test it. And well, we think that the future maybe can happen in just one mainnet, and we can start growing vertically. So we are going to do a demo of how easy it is to deploy an EVVM.
So it's more easy than you think deploying a EVVM. I'm gonna put this part of the repo. So it is a testnet contract. So you can see around, check it out for yourself, but we're gonna deploy it. So all the contracts are constructed in Foundry. So we have a make file to set up the process. Right now we're gonna set up to Arbitrum. So I'm gonna okay. So we're gonna deploy it. Make deploy testnet, and right now we compile it. They ask for my password, and right now we're deploying an EVVM inside the Arbitrum ecosystem. So we have the verification, and we have the esmate. We're gonna wait for the EVVM, but while we're waiting, let me analyze some parts of the contract. So if you want to personalize EVVM as a proxy, you can make it in the create proposal implementation. You can use a proxy to add some AIP, testing some AIP, or maybe add some more things inside the EVVM. So we had a create proposal implementation. There is a proposal. We had a waiting time for 20 days. And is completely rejectable. So if it doesn't pass the time, or even so pass the time, you can reject the implementation. And after the waiting time, you can accept that proposal implementation. Some interesting things about the proxy is, let me put it in right now. Yeah. So we had a small test, and we had the implementation that is inherited by the storage, and you can interact you want storage from that contract to the EVVM contract and vice versa. So you have a more easy to implement proxy. So let me find right now the EVVM. So we have that. And right now we're gonna make a simple payment execution. So we're gonna write this contract, and because it's a testnet, you can get your own faucet. So with the add balance, you can mark what user gonna get the tokens, what tokens gonna get, and the quantity. And because their tokens inside the EVVM doesn't need any permission, doesn't need any part. So we're gonna add the from. We're gonna add the token, and we're gonna put a small amount. We're gonna connect, right, and yeah. And after that, we're gonna make a small payment. So if you see from the left, you see a small transaction. Imagine it's a finished spot. So as a fisher, we're gonna get this type of transactions. So we're gonna go to the pay staking async. And why? Because async. We had two types of nonces. So
yes, we have, in the meanwhile, Kevin is configuring this. What executors are for is like the only ones, like in a voucher, can execute a transaction, but it's not on their behalf, it's in behalf of a third party. So in place of giving permission to a contract or to an account to do something in your behalf, you just put it inside the transaction. This is great for swaps, because in example, you don't need to approve a token and then give a transaction permissions to do a swap for you. You just do that in one transaction. And regarding the nonce, also some improvement that the EVVM has is they have synchronic nonce and asynchronic nonce. So in example, you can go one by one like normally. So you have transactions that are pre-required to have another step before. Or maybe you just want to throw a transaction that maybe is urgent because you have many pending transactions, but this one doesn't mean to have just a non-used nonce before. So this will pass immediately. And or also you can, in example, say, okay, I have 1 week to pay my gas receipt. So you make this transaction, you give it to the gas company with an asynchronic nonce, and this will be processed by the gas company. You will be paying because it's in your behalf, and this will go maybe in 2 days, 3 days, 4 days, and you don't care about it. So this is just some use cases, and for a swap, it's like, so now Kevin is going to try to execute a transaction that is from an account, but is with the wrong executor, because was not allowed. So this transaction will not pass. We can see it. We are making this manually, of course. You can code your dApp. Okay. Of course, this is a revert alert there, but now you need to disconnect and connect again with the right account. And well, this is to show you how easy it is to deploy an EVVM. You can check the code. The code is open source. It's free for personal use and also for educational purposes. For commercial use, you have to talk with us. But feel free to get that repo, clone it, play with it, and of course, talk with us if you have any doubt, any question. So for reference, in the meanwhile, we see how this now will go. This will go through because it's the correct executor. What we aim to is to have like virtualized blockchains now, as in the past we have dedicated servers with dedicated infra. Then the VPS came, the virtual private servers that were deployed in one hardware. This was, of course, for having more optimizations, and now we have the cloud. Well, we think that the blockchain future will be similar. Now we have one blockchain, two blockchains with a lot of infra. You can rent infra, have infra as a service, but we think that maybe with the current infrastructure, if we start virtualizing blockchains on blockchains, we can have more scalability, more ease to use also for the financial institution, banks, governments to have their own chains on the most secure chains. Yeah. Okay, this went through. Thank you. Thank you for being here and listening to us.